All right, let's talk about something that you interact with every single day, but probably never think about. It's called non-functional testing. And today we're going to pull back the curtain and see what it really takes for an app to go from just kind of working to working incredibly well. Let's get into it. Oh, you know the feeling. We've all been there. You're scrambling to buy those concert tickets the moment they drop, or you're trying to navigate somewhere important and bam, the app just dies. It slows to a crawl, it freezes, it crashes. It's beyond frustrating, right? And the thing is, the reason it crashed probably wasn't about what the app was supposed to do. It was all about how well it could do it under pressure. Here's the absolute best way to think about this. Imagine you're checking out a car. A functional test asks one simple question. Does the engine start? Yep, cool, it works. But that's not enough, is it? Non-functional testing asks the questions you really care about. How fast does it go from 0 to 60? How much stuff can you cram in the trunk? What happens when you hit a bumpy road? It's all about the quality and the experience, not just the basic on-off switch. And that gets us to the heart of the matter. For pretty much any software you use, just working is the bare minimum. It's nowhere near enough. Exactly. It's not about checking off a list of features. Non-functional testing is about understanding the software's character. You know, is it quick? Is it stable? Can you depend on it? Answering these questions is what separates the apps you love from the ones you delete in frustration. So how do we actually measure how well something works? Well, we look at a group of qualities that a lot of developers call the ig-abilities. Think of them like the tech specs for software quality. First up is usability. Let's go back to our car. Usability is that feeling of everything being in the right place. The comfy seats, the intuitive dashboard, the smooth handling, basically how easy and, dare I say, pleasant is it to drive. For software, this means you can just pick it up and it makes sense. It's not a puzzle you have to solve. Next, we've got reliability. This one's all about trust. Can you take that car on a 5-hour road trip in the middle of summer and trust it not to overheat? In the software world, it's the same exact principle. Can this app run for hours without glitching or crashing? You have to be able to depend on it. And let's talk about efficiency. A car with amazing gas mileage gets you further on less fuel. Simple, right? Well, software efficiency is the same idea, but the fuel is your phone's processor, its memory, and most importantly, its battery. An efficient app does its job without sucking your battery dry by lunchtime. Okay. So we know what we're looking for, but how do we actually test for these things? Let's get into some specific methods, starting with a couple that are all about speed and handling a crowd. The first one is performance testing, and this is all about a single person's experience, your experience. When you tap a button, how fast does the app react? We're talking fractions of a second. The whole point is to make the app feel instant and snappy, just for you. But what happens when it's not just you? That's where load testing comes in. This asks a totally different question. How does the system hold up when hundreds or even thousands of people are all trying to use it at the exact same time? It's like simulating rush hour to make sure there are no traffic jams.
And the car analogy just makes this so clear. A performance test is like timing a car 0 to 60 with only the driver inside. But a load test, that's timing it again. But this time every single seat is filled and the trunk is packed with luggage. You see the difference? It's easy to be fast when you're by yourself. A full load changes the entire game.
Okay, but what about when things get weird? When the load isn't just heavy, it's totally unexpected. That's where this next round of tests comes in. These are designed to find the system's absolute breaking point.
So imagine you're watching the engineers test a new shopping website. With 10 users online, no problem. Everything's snappy. 250 users, still looking good. But then you hit 499 users, and you can see it start to sweat. Pages load slowly, things get sluggish, and then that 500th person logs on and error. The whole thing falls over. Finding that number is exactly the point. You want to find it in a test, not on launch day. This whole process is called stress testing. You are intentionally pushing the system past what it's built for just to see what happens when it breaks. You're not testing for a normal Tuesday afternoon. You're simulating Black Friday chaos. The goal is to see how it behaves under the absolute worst conditions. And stress isn't just about a flood of users. It's about a whole cocktail of digital nightmares. What happens if the server is running out of memory or the hard drive is almost full? The goal isn't just to see if it breaks, but how it breaks. Does it crash gracefully and give a helpful error message? Or does it just, go up in a puff of smoke?
And one last one, volume testing. Now this is a bit different. We're shifting our focus away from the number of users and onto the sheer amount of data. Think about your favorite social media app. It's one thing to make sure it works with 100 posts in the database. It's a whole other challenge to make sure it works with 1 billion posts. You see, testing with just a tiny, clean sample of data, that's like driving on a perfectly paved, empty racetrack. Of course it's going to perform well, but that's not the real world. The real world is messy and enormous. The real world is trying to run a search that has to sift through millions and millions of records. That search that felt instant with 100 items, how does it feel with 100 million? That's what volume testing is all about, making sure the software doesn't choke when the data gets huge.
So, we've looked at all these different ways to push, pull, and prod a piece of software. Let's tie it all together and talk about why this is so incredibly important for the tech we all use.
So let's just do a quick recap. Performance is about speed for one person. Load is about handling a crowd. Stress is about surviving extreme conditions, and volume is about dealing with massive amounts of data. You see how they all cover a different angle? It's this combination, this full suite of tests, that takes a program from something that just functions to something that's genuinely robust, reliable, and a pleasure to use.
So I'll leave you with this. The next time you're using an app during a massive event, a holiday sale, a big game, a breaking news story, and it just works flawlessly, take a second. Think about the invisible gauntlet it had to run. Think about the stress, the load, the volume it was built to survive so that your experience could be perfect. It's not an accident. It's really, really good engineering. Thanks for diving into this with me.